So we have 18 marbles in a bag. 6 of them are red, 4 of them are green, and 8 of them are blue. And we pull 3 marbles randomly, first with and then without replacement. And we have to find the following probabilities. First, let's start with replacement. So we pull out 3 marbles randomly. What is the probability that all 3 of them are red? So the first marble is 6 out of 18, which is 1/3. And then because we throw it back, the next one is also 6 out of 18. And the next one is also 6 out of 18. So altogether we have 1/3 times 1/3 times 1/3, which is 1/27. Things become interesting when we have no replacement, because then whatever we did before affects the probabilities. So when we pull the first marble, again 6 out of 18 will be the probability of we pull a marble. But now that marble is set aside, we no longer have 18 marbles in the bag, and not 6 of them are red, right? We only have 17 marbles and only 5 of them are red. And for the next one, we only have 16 marbles and only 4 of them are red. And then let's notice that there are lots of cancellations. The first one is 1/3, then nothing happens here for us, and this is 1/4. And so we have 5 divided by 12 times 17. And that is 5/204. Before we move on, there's one more note I'd like to make. So the question is, out of the 18 marbles, what is the probability that we choose 3 red marbles, provided that 6 of them are red? There is an older approach that we can use here. Basically, the how many out of how many using combination. So what would be the total number of cases? We're selecting 3 marbles out of 18. That should be 18 choose 3. So 18 choose 3 should be the denominator in this probability. And what would be the numerator? The total number of ways we can select 3 red marbles. Well, that means that all 3 of those marbles must be selected from these 6 red marbles. So that would be 6 choose 3. And so this should give us the same correct answer. Well, let's see. 6 choose 3 is 6 times 5 times 4 divided by 3 times 2 times 1. And 18 choose 3 is 18 times 17 times 16 divided by 3 times 2 times 1. To divide is to multiply by the reciprocal. And now if we cancel out the 3 factorial, look at this product in the numerator. 6 times 5 times 4, 6 times 5 times 4, and in the denominator 18 times 17 times 16, 18 times 17 times 16. So both approach will give us the same answer, namely 5/204. Okay, so the next question, same scenarios. Same bag with the same marbles, and we're pulling out 3 marbles, first with replacement, then without replacement. But now the question is, what is the probability that the 3 marbles pulled out have the same color? Well, that can happen in 3 different ways. We can pull out a red and a red and a red, but that's not the only possibility, right? We can pull out 3 green ones, and we can also pull out 3 blue ones. With replacement, pulling out a red is still that 6 out of 18. Pulling out a green is 4 out of 18. And pulling out 3 blue marbles is 8 out of 18 for the first, the second, and the third time. That's what replacement does. Okay, so we can simplify this. Let's just try simplifying this. This is 1/3 times 1/3 times 1/3. That's 1/27. We have already computed this. And the second one is 2/9 times 2/9 times 2/9, which is 8/9 to the 3rd power, 729. For the blue, we can divide by 2, so that's 4 out of 9 times 4 out of 9 times 4 out of 9. So the denominator is the same 729, but now the numerator is 4 times 4 times 4, which is 64. So the question is, what do we have to multiply both numerator and denominator to get from 27 to a denominator of 729? That's a division question. So it appears, it looks like this is 27 squared. So we're going to multiply upstairs and downstairs by 27. And then we have the common denominator of 729. And the numerator is 27 plus 8 plus 64, which is 99 over 729. It's good to remember that the denominator is 27 times 27, which means both numerator and denominator are divisible by 9 at least. If we divide 99 by 9, we get 11. And 729 divided by 9, that should be 81. So 11 over 81 is the probability. Now for the fun. When we have no replacement, this problem is going to be much more computational. It doesn't matter whether we have replacement or no replacement. These are the possibilities: 3 red, 3 green, or 3 blue. For the 3 red, so pulling out 3 red marbles without replacement is 6 out of 18 for the first marble, 5 out of 17 for the second, and 4 out of 16 for the third. Now for 3 green. So we start with 4 out of 18, and then after we pulled out 1 green, now there is just 3 out of the 17, and finally just 2 out of 16. And notice that the denominator is going to be the same. Finally, 3 blue, that would be 8 over 18 for the first marble, 7 over 17 for the second one, and 6 over 16 for the third one. Let's just bring the whole thing to the common denominator, which is 18 times 17 times 16. And let's remember this, because when we're looking for common divisors, it's going to be whatever 18 or 17 or 16 has. When we multiply those three, we get 4,896. 5 times 4 is 20, 6 times 2 is 12, 6 times 20 is 120, 4 times 3 is 12, times 2 is 24, 6 times 7 is 42, 8 times 42 is 336. And this is a significantly larger number, but it does make sense because we have the most marbles are blue, almost half of them, right? So we add the numbers in the numerator and we get, this is kind of nice, 480 divided by 4,896. So this has a lot of divisors too. 48 is 3 times 16, so we can definitely divide out by 16. So if we divide 480 by 16, we get 30. And if we divide the denominator by 16, we should get that 18 times 17, right? So that's 306. They are still both even, so let's divide by 2. We get 15 in the numerator and 153 in the denominator. Now 15 is only divisible by 3 and by 5. I circled it too soon. If you add the digits of 153, you notice that all three they add up to 9, so that means that it's divisible by 3. So if we divide the top by 3, we get 5, and 153 divided by 3 is 51. And now this is for sure reduced because 5 is only divisible by 5 and 51 isn't. If this was 50, it would be just 1 over 10. All right. So now the question is, what is the probability of getting 3 marbles of different colors? Now we're going to have to look at things like, well, we can pull the first one red, the second one green, and the third one blue, or first one red, the second one blue, the third one green, and we're done with the ones that start with the red. So let's see, blue, red, green, blue, green, red, and then green, red, blue, green, blue, red. Looks like it's a lot of work, but you will see that luckily these chains have the same probability, so we can just compute 1 and multiply it by 6. And that's going to be the case in case of replacement and no replacement. Let's see the probability for this. With replacement, it would be 6 red out of 18. The second one is 4 green out of 18, and the third one is 8 out of 18. So it looks like there is some cancellation here. This is just 1/3. We can get rid of a 2 here, so that's 2 over 9. And we can get rid of a 2 here, that's 4 over 9. The denominator is 3 times 9 times 9, which is 243. And the numerator is 1 times 2 times 4, that's 8. What happens if we pull a red first, then a blue, then a green? Then it's going to be 6 out of 18 times, and now first the 8 out of 18, and then the 4 out of 18. But multiplication is commutative, which is to say it doesn't matter the order of the factors, we get the same result. So each of these chain of events has the same probability, and that is 8 over 243. So the probability of 3 different colors is 6 times 8 over 243. Remember that there is a lot of 3 in the denominator, so we can cancel out a 3. Then we have 2 times 8 divided by 81, and that's it, 16 over 81. Kind of interesting that both numerator and denominator is a square. Okay, now let's answer the same question, but this time no replacement. So the first one being red, the probability is 6 out of 18, and the denominators will shrink by 1, right? As we pull out the first marble, we're down to 17, we pull another one, we're down to 16. However, because we keep pulling different ones, how many green? After we pulled out red, we still have all 4 green in there. And after we pull the red and the green, we still have all 8 blue in there. And that's going to be the case with all the other 5, that the denominator is going to be 18, 17, 16, and the numerator is just going to be a permutation of 6, 4, and 8. Let's see if we can simplify. So 6 over 18, that's 1/3. 4 over 17, nothing going on there, and this is just 1/2. And so there is one more. We can cancel out the 2 here, so then we have 2 over, the 2 is gone, 3 times 17, 51. That's the probability of first red, then green, then blue. And so the probability that the 3 marbles have different colors is going to be 6 times 2 out of 51. There is a cancellation here, so it's 4 out of 17. Thank you for watching.